today we are going to talk about parabolas. Parabola, just like circle, is composed of set of all points. When combined all together, it will form a curve, just like what you can see at the figure. So suppose we have here a point F with coordinates 0 and 2, and point A with coordinates 4 and 2, and a line that has an equation of y is equal to -2. So what we are going to do here is we are going to determine the distances from point F to point A, and also the distance from point A to the line over here. So let's determine first the distance of our line FA. So we can easily determine the distance of our line FA by simply counting over here. So we have 1, 2, 3, 4. So the distances from point A to point A is equal to 4. Now, how about for our distances from point A to our line? So, point A to our line, we will have here, or we will name it AL. Means point A to our line over here. So, again, we can just simply count this one. So, let's try to count the distances. We have 1, 2, 3, and 4. So therefore, the distance from point A to L is also equal to 4. Now, let us compare. As you can see, line FA and AL are the same or equal, or they have an equal distances. Okay, so line FA versus AL are equal. Let's try another one. So we have here point B with coordinates -8 and 8. So just like what we did previously, we are going to find the distances from point B to our point F and the distances from our point B to our line over here. So there are instances that you cannot actually count the distances, just like what we have here, point B to point F. So what we are going to do, since the endpoints are given, we are going to solve it using our distance formula. So we have here our formula. Ta-da! So distance is equal to square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. Okay, so let's say our B here is our first point and our point F is our second point. So negative 8 here will be our x sub 1. 8 is our y sub 1, F, x sub 2, and 2 is y sub 2. Sige, let's try to solve. We have here square root of our x sub 2 is 0 minus x sub 1, which is -8. Then squared plus our y sub 2, which is 2, minus our y sub 1, which is equal to 8 squared. Okay, let's automatically use our calculator. So our distance is equal to is equal to 10. Okay. So we all know that from point B to our point F, our distance is equal to 10. Now, is it also equal if we are going to find the distance from point B to our line? So since we can count them, let's just count how far is point B to our line over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They also have the same distances. So, in short, when we say parabola, it is the set of all points P such that its distances from F and from L are the same. F here is what we call the focus, or as you can see in the figure, focus is located over here inside our parabola. Okay? Focus is usually C units above or below our vertex. Okay. It is also the same with our directrix or our line over here. Directrix is C units below or above the vertex. So they have the same definition with directrix and focus. The only difference is that focus is a point located inside the parabola, while when we say directrix, it is a line located outside the parabola. So again, when we say parabola, it is the set of all points P such that its distances from focus and from L or our directrix are the same. Okay. And also, we must not forget our vertex. When we say vertex, if our origin is at coordinates 0 and 0, if the parabola opens upward, just like our figure, the vertex is the lowest point. So our lowest point here is located at the origin. So this is what we call the vertex. However, if the vertex or the parabola opens downward, therefore our vertex should be at the highest points. We will see another example for that. Okay. And also, last but not the least, we have the axis of symmetry. It means it is a mirror images of each other. If we are going to divide our parabola or cut them into half, we can see mirror images of each other. It means they are all equal. Mirror. Okay. Sige. Wait for part 2.